So in addition to the differences in the auction types, where bidders have different information about other bidders, okay, bidders will have different information about their own valuation of what's being auctioned. Okay, so you might have perfect information about the value of the item. Okay, and this is rare. Part of that's because one reason why sellers would choose an auction format is because there is uncertainty about the value of the auction. Okay, and there's independent private values. Okay, and these are values determined by bidders' own taste and preferences. And for an example of that, you might check out this 6.5 minute clip from the Dick Van Dyke Show, episode titled The Masterpiece, and this was from 1963. And here, Rob and Laura are looking at an item, and Laura has taste and preferences in favor of this item. Okay, and then things get funny. Okay, and then the third type of information structure is when there are affiliated value estimates, and this is when each of the bidders have correlated value estimates. And special case is with common value auctions. Okay, so given the type of auction and the information structure, let's think about optimal bidding strategies. And we are going to focus our attention on risk-neutral bidders because that's the easiest situation. Okay, we could also think about risk-averse or risk-loving bidders, but we won't because it complicates things. And think about risk-neutral bidders is a good place to start. Okay, so first of all, an optimal bidding strategy is the one that maximizes the bidder's expected profit. Okay, so we have business firms who are trying to maximize profit, or any kind of buyers who are trying to maximize profit. And if you're the business firm trying to choose the type of auction to generate the most revenue, okay, that's the information, the bit of information that you need to know about your bidders. They're trying to do the best they can, and so are you. Okay, so optimal bids depend on the type of option and the information available to bidders. Okay, so let's think about private value auctions. Okay, so in this situation, bidders know their own values prior to the auction start. Okay, so let's imagine you know how much something is worth to you, and you have a dollar figure in mind. Okay, and let's say if these values, we'll call them V. Okay, if your value is 100, then in an English auction, okay, you want to stay in the bidding, you want to remain active until the price rises above $100. So if you bid $100 and the thing is worth $100 to you, you give up 100, you get $100 back in value, and so you've broken even. Okay, in a second price sealed bid auction, okay, you want to bid your valuation of the item. Okay, and if we're thinking of this as a game, this is a dominant strategy. Okay, if you bid $100, and that's the highest bid, and the next highest bid is $90, and you lose, then you lose $90. You pay the second bid, the second highest bid, the second price, and you receive an item that's worth $100 to you. So you've just gained $10. And then the Dutch and the first price seal bid auctions have similar strategies. Okay, but they're more complicated than strategies in an English auction and a second price seal bid auction. And that's because bidders are trying to maximize profit. Okay, and so you want to try to avoid paying the value for the product or the item. Okay, so with independent private values, okay, meaning people know their own value, but they're different from all the other bidders. Okay, so what you want to do is bid less than your value. Okay, so if the bid is B and the value is V, you want to bid less than the value by this term here. Okay, so one assumption behind the simple formula, which again is a good place to start for our analysis, and it's also where we will end. There's a huge economic literature on auction theory, and this is our introduction to that. Okay, so imagine there are N bidders, where N could be anywhere from 2 to 2,000. Okay, and they all have a different private valuation of the item. And let's assume that these valuations are uniformly distributed between a low number, L, which might be the reserve price for an auction, okay, the lowest price that you can bid, and H, which is the highest bid. Okay, so this formula B down here is the optimal bid for each player, each bidder who have a value of V. Okay, so the book just writes down this formula and says that that's what it is. But let's dig a little bit deeper and try to see where this formula may have come from. Okay, so first of all, the bidder's problem or goal is to maximize expected profit. So here we have expected profit on the left-hand side of this equation. And profit depends on two things. The probability that you win the item, and that's a function of your bid. Okay, and then multiplied by the difference between the value that you have for the item and the bid. Okay, so if the value of the item is $100 to you, and you bid 90, and you end up paying $90, then your profit is 10, but only if you win the item. Okay, so there's tension between these two terms. The higher you bid, the greater your probability of winning, but also the less profit that you receive if you win the item. Okay, so let me get rid of this guy, just repeated that. Okay, so the probability that you're going to win the item depends on the number of bidders. Okay, as the number of bidders increases, competition for the item increases, and the chance that you win the item decreases. So as the number of bidders increase, the optimal bidder is going to want to increase their bid. Okay, so one way to think about that is the optimal bid, B star. One strategy is to shade your bid by this fraction. Okay, n minus 1, number of bidders minus 1, divided by the number of bidders. You can see what percentage that this formula suggests that you bid. If there's 2 bidders, then the percentage of a value should be 50%. If there's 4 bidders, the percentage of value you bid should be 75%. If there's 8 bidders, 88%, and all the way to, and let's keep doubling the number of bidders till we get to 32. and that would be 97% of your bid. So you can see how, as the number of bidders increase, the optimal bidding strategy for risk-neutral bidders increase from 50% to almost 100%. Okay, so what does this formula have to do with the earlier formula we saw? Okay, the one that's written down in the book. Okay, so I'm just going to multiply through V through the parentheses, and that's the second term down here. So V times N minus V over N. Okay, and then we will separate this fraction into two since they have a common denominator. So V over N divided by N minus V over N. Okay, we're just doing some algebra here. And since V over N divided by N is just V, okay, then the optimal bid is equal to V minus V over N, okay, where V is the value. And when there is a reservation bid, or we know that the lowest bid, the lowest value that's out there among the bidders is a number L, then you can adjust that formula by subtracting L from the numerator. And so B star, I've added star here because that's the optimal bid, is equal to V, and you want to shade your bid or reduce your bid by this term on the right. Okay, so let's see how that works. So consider an auction where bidders have independent private values. Each bidder thinks that valuations are evenly distributed between $1 and $10. Okay, so you know that the lowest value that someone has out there is 1, and you think the highest value that someone has out there is 10. So we have a bidder named Sam. He knows his own valuation is $8. So what's Sam's optimal bidding strategy? In a first price sealed bid auction with 2 bidders, and a Dutch auction with 3 bidders, and a second price sealed bid auction with 20 bidders. Okay, so in the first price sealed bid auction with 2 bidders, we just plug those numbers into the formula. So 8 minus 1 over 2, then the optimal bid is $4.50. Okay, in a Dutch auction with a descending bid, we use the same formula, but now we have 3 bidders. So as the number of bidders increases from 2 to 3, there's more competition, so we're going to want to raise our bid and then plug in the numbers into the formula. Our new bid would be $5.67. Okay, and then remember, in a second price sealed bid auction, you just want to bid your value. So doesn't matter how many bidders there are. Here we have 20. It could be 2 bidders. Our optimal bid is going to be $8.